Let's take a look at a better buy problem. We're going to compare gas station 1, gas station 2, and gas station 3. We're going to see which station has the best price for gasoline. We've been given the information in three different forms. We've been given an equation, a table of values, and, of course, a graph. And you can see by the graph that it certainly is proportional. It's straight, and it starts at the origin, 0, 0. Now, in each case, we want to find the cost per 1 gallon of gas. Remember, cost will be the top value in our ratio, and the gallons amount will be in the denominator. So the cost per 1 gallon of gas. And in fact, when we figure this out, we're going to compare the three gas stations. Let's take a look at our first station, station number 1. We've been given an equation. What does that equation truly mean? Well, remember, it's proportional, and it's K times X equals Y. That's the basic structure, where 2.6 represents our rate. What that really means is $2.60 times every gallon of gas, X, equals Y, the total cost. If we had been given the option to select our own variables, we may have even done something like this. $2.60 times every gallon G equals T, the total cost. But for now, this is a proportional relationship, and we can see that the K rate is $2.60 per every 1 gallon of gas. Had the equation looked something like this, 2.6x plus $3 equals Y, that would not have been a proportional relationship because of the plus 3 constant. So this equation fits our format of K times X equals Y. We know it's proportional, and we know that the rate for this gas station is $2.60 per 1 gallon. Now let's work with our table. We're going to check each ratio in the table and determine the unit rate. $4.80 divided by 2 gallons of gas, $7.20 divided by 3 gallons of gas, and finally, to run the ratio test, we have to do this with every pair, every XY pair we've been given. We get $9.60 divided by 4 gallons. Take a moment, grab your calculator, and get the rate for each one of these ratios. You should have gotten 2.4 for each of these ratios. What does that mean within the context of the problem? That means, let's dress it up like money, that it costs $2.40 for every 1 gallon of gas at station number 2. And finally, let's take a look at the graph, number 3. You can see that it's straight and it starts at 0, 0. Clearly, it's proportional. But how much does a gallon of gas cost at station 3? We're going to grab some ordered pairs off this line and calculate the K rate. For example, this first ordered pair states 2 gallons for $5. Another easy readable point would be this point right here. It states for 4 gallons of gas, it costs $10. Let's calculate the rate for each of these ordered pairs. Think about it. My suggestion is anytime you get a graph, create a small table for yourself and pull a few points off the line. 2 gallons for $5, 4 gallons for $10. Now let's set up a ratio for each of these. $5, we're going to put Y over X for 2 gallons, and for the next one, $10 for 4 gallons. Now calculate a rate for each one of these ratios. Pause the video and use the calculator on your phone. Your rate in each case is 2.5. Written as a ratio, you would say $2.50 per 1 gallon of gas. Now compare. All things even, which station has the best price? Station 1 at $2.60 per 1 gallon, Station 2 at $2.40 per gallon, or Station 3, which is $2.50 per gallon. Clearly, the better buy is station number 2. You should record these notes in your notebook and get ready to take an exit quiz. There are no problems being assigned for homework today.